Good morning, children. Today's class we are going to learn about relations. See, you all have relatives at home, father, mother, auntie, uncle, like that. In mathematics, what does relation mean? Take two sets A, B. The Cartesian product we call as A cross B. Relation R is a subset of A cross B. So we are taking two non-empty sets, say A and B. Find the Cartesian product. R we denote as relation, which is a subset of A cross B. Supposing I take a non-empty set S and R is a relation in S such a way that A is related to A. Every A in S, for every A, this symbol we call for every. For every A related to A comes correct. We call the relation is reflexive. The word reflex means reflexive, A to A itself. Stand in the mirror, near the mirror, you see your own self. So reflecting. A related to A implies it is reflexive. A related to B implies B related to A. For example, sister. A is a sister of B. Can it imply B is also a sister of A? Sometimes there may be a brother also. So, in that case, I don't say right. But A is a friend of B implies B is a friend of A. Is a friend of, is a relation. So, we call that as symmetric. A to B implies B to A. That idea we call symmetric. The third idea is transitive. A related to B and B related to C. In that case, A related to C. See, B I can cancel. A to C is possible. So, this idea we call transitive. A relation that follows all the three, we call it as equivalence relation. So, this exercise we are going to check whether the given relations are following reflexive, symmetric, transitive ideas. If so, let us declare it is an equivalence relation. Now the idea is the biggest relation we call universal relation. For any set A cross A is called the universal relation and we call MT relation as phi. A cross A is the universal relation containing all the ordered pairs in A cross A. So this is universal and I declare this is an equivalence relation. A cross A is always an equivalence relation. But when you come to phi, the first idea reflexive. I want to show A related to A, but there is no such A in phi. So, phi is not reflexive. Second idea, symmetric. Whenever A related to B, I want to show B related to A. But there is no A related to B I am able to show in phi. In that case, this implies is not making sense. So, I will say this is symmetric. Because symmetric I can declare whenever A is related to B, I want to show B related to A. A related to B not available, I need not show B related to A. So, MT relation is always symmetric. The same idea with transitive. Whenever A related to B and B related to A, I want to show A related to, B related to C, I want to show A related to C. Whenever A related to B and B is related to C, I want to show A is related to C. But in empty relation, there is no A related to B or B related to C. I need not show A related to C then. So automatically I can declare this is transitive. So remember, it may come in your objective type questions. MT relation is always symmetric and transitive but not reflexive. Now there is yet another set, singleton sets we say. So whenever a relation contains single element, whenever a relation contains single element, in that case I will say the relation is only transitive. Like singleton set, the relation having only one element, we call it is transitive because it is having only one element. A to B I cannot show. So that particular set we call singleton element is there, then it is called transitive. Now we'll go on to the exercise problems and discuss this relation idea in depth. Exercise 1.2, question number 1, subsection 1. We need to discuss reflexivity, symmetricity and transitivity. The relation R is defined on set of all positive integers. What is the relation R? In this question, M is related to N implies M divides N. What is this idea divides? I will say 2 divides 4. 4 is a multiple of 2. That is the thing we say 2 divides 4. I can also say 4 divides 12. So this number should be smaller and this number should come in this table, multiplication table. 4 comes in 2 table, 12 comes in 4 table. So this is just an idea for you. Divides implies this must be a small number, this must be a bigger number and a multiple of this. Well, coming back to the question. First, I want to show reflexive. Check whether it is true. M or M. Is it correct? M divides M. Can I say it or not? 2 is 1 time 2. 4 is 1 time 4. So 2 divides 2 is correct. So M or M implies M divides M, which is true. Therefore, R is reflexive. The next idea, symmetric. Symmetric, what is the formula? If M is related to N. What is M related to N idea? M divides N. Like 2 divides 4. Can I say 4 divides 2? 2 divides 4 is correct. 4 divides 12 is correct. 4 divides 2, is it correct? No, wrong, because this is bigger and this is smaller. I will get a fraction, that is wrong. 2 is not a multiple of 4. So 2 divides 4 does not imply 4 divides 2. So M is related to N implies M divides N. Then N is related to M implies N divides M. This is wrong. So I will say it is not correct. N does not relate to M. So I will declare not symmetric. Which is not symmetric? R is not symmetric. R only we denote as the relation. The next idea, transitive. Check our example itself. 2 divides 4, 4 divides 12. Does it mean, cancel 4 and 4, 2 divides 12, is it correct? Yes. 2 divides 12 is correct. So, M or N implies M divides N. N or say some other letter, any other letter I can say. P implies N divides P. Here M is smaller, N bigger. Here N is smaller, P is bigger. So from this idea, 2 divides 4, 4 divides 12 implies 2 divides 12. Same idea, I can say this implies M related to P or M divides P. So R is transitive. So we are checking the given relation. What is the relation? Divides. M divides N. Any number divides itself. So it is true, therefore reflexive. M divides N does not imply N divides M. So we say not symmetric. M divides N and N divides P implies M divides P. Therefore R is transitive. Second subsection, P denotes the set of all straight lines in a plane. Lines, any lines I can say on a plane. The relation R is defined by L is related to M implies L is perpendicular to M. See, we have taken L a line, M another line. L is related to M if and only they are perpendicular. So what is my first case? I have to check reflexive. L related to L. What does it mean? If L is perpendicular to L. Is it correct? Wrong. Is it correct? Any line is not perpendicular to itself. So L related to L is wrong. So we say L is not related to L. R is not reflexive. The second idea, not reflexive. Let us underline to remember. The second idea, symmetric. L is perpendicular to M. L is perpendicular to M. Does it mean M is perpendicular to L? Yes. M related to L implies M is perpendicular to L. L is perpendicular to M implies M is perpendicular to L. Therefore, we say LRM implies MRL. Therefore, R is symmetric. Whenever I say first line is perpendicular to second line is also perpendicular to the first line. Now the third idea. Remember one more line I am drawing. What about this N? N is perpendicular to M. Or I can say M perpendicular to N. Now L related to M implies L perpendicular to M. The second idea. M related to N implies M perpendicular to N. Now L perpendicular to M, M perpendicular to N. Cancel M and M. Can I say L perpendicular to N? Is L perpendicular to N? I will say L and N are parallel. They are not perpendicular. My question is, if I hide this L, M and M, I want to show L is perpendicular to N. So we will say this implies L perpendicular to N is wrong. Since I can say L and N are parallel, therefore I will declare the given relation is not transitive. So is perpendicular to is the relation here. I can say the given line is not perpendicular to itself, not reflexive. If L is perpendicular to M, we understand M is perpendicular to L. So is perpendicular to, the relation is symmetric. If L is perpendicular to M and M is perpendicular to N, L is not perpendicular to N, it is only parallel. So R is not transitive. That is the answer. Third subsection, A is a set of family members. The relation R is defined by A or B if A is not a sister of B. Understand the concept, not a sister. See, we can say A is not a sister of A. Is it true or false? A is a person. That person cannot be a sister of himself or herself. So A is not a sister of A is true. So I will say A related to A. A is not a sister of A. So I will say A related to A. R is reflexive. The second idea, whenever A is not a sister of B, A is not a sister of B. This is A related to B. Can you say B is not a sister of A? Then we must give some example. If I want to say it is wrong, give some example. See, father is there, mother is there, family. And let me take sister 1, sister 2 and brother 1. So this is a family. Father, mother, sister 1, sister 2 and there is a brother. I will say B1 is a brother, is not a sister of S1. B1 is not a sister of S1. But what will you say? S1 is a sister of B1. So this is brother and these two are sisters. So I will say B1 brother is not a sister of S1 but S1 is the sister of B1. So I will say A is not a sister of B does not imply B is not a sister of A. So we say R is not symmetric. B is not related to A. So A is not a sister of B, but B can be a sister of A. So this idea tells me R is not symmetric. The next idea, take sister 1. She is not a sister of father. Correct. S1 not a sister of father. Father not a sister of the second daughter, say S2. S1 is not a sister of F. F is not a sister of S2. But S1 and S2 are sisters. So I say A is not a sister of B. B is not a sister of C. Does not imply A is not a sister of C. Here we have given an example. First sister is not father, not a sister of S2. First sister, not a sister of father. But S1 and S2 are sisters. So A is not a sister of B, B is not a sister of C, need not imply A is not a sister of C. So I will declare R is not transitive. So we have to give it a notation. A R B and B R C does not imply A R C. So the relation is not transitive, not symmetric, but reflexive. Question number 1, subsection 4. The same idea, not a sister of. But the question redefines the set. We have female members of the family. Female members tells mother, sister 1, 2, 3 only. No brothers, no father. So only the female members of the family we consider. What is the first thing I have to say? Reflexive. A related to A. Yes, A is not a sister of A. So this is correct. I will say R is reflexive. The second idea I want to say symmetric. There are only sisters and mother. If mother is not a sister of this one, then this is not a sister of mother. So the idea I say A related to B implies A is not a sister of B, then this implies B related to A. That is, B is not a sister of A, because now there is no idea of brother or father. So whenever A is not a sister of B, I can immediately say B is not a sister of A. So A related to B implies B related to A, and I will conclude R is symmetric. The next idea, transitive. Daughter 1, that is A, not a sister of mother. Call her as B. B, mother, not a sister of daughter 2. Call her as C. So A is not a sister of B. B is not a sister of C, but A and C are sisters. Therefore, not a sister of is not transitive. Remember, not a sister of, we discussed the same in the earlier problem where it is just the members of the family. Even if it is female members of the family, A related to B, B related to C does not imply A related to C. Therefore, this relation is not transitive. Therefore, even when we consider female members of the family not a sister, the relation is not an equivalence relation. Subsection 5, on the set of all natural numbers. So what do you mean by natural numbers? 1, 2, 3, 4 and so on. The relation R is defined by X is related to Y if X plus 2Y equal to 1. Can you say some numbers, some natural numbers for X and Y? Supposing I take 2 and 3. 2 plus 2 into 3, will it be equal to 1? 1 is the least natural number. 1 is the smallest natural number. Adding two natural numbers will not give me 1. So this is an empty relation. I cannot say even one element suiting this one. So this is an empty relation, and we know empty relation is not reflexive but symmetric and transitive. So let us remember this idea what we had heard in the introduction. Empty relation is not reflexive but symmetric and transitive. So this is a simple problem. I need not even show how all that. I am able to say immediately this is an empty relation. Why? Natural numbers start from 1. The relation says adding two natural number I must get 1. By adding two numbers I will never get 1 because I am in the set N. So again I say the set defines whether these relations are correct. So in N this relation will not work out. It is an empty relation. An empty relation is not reflexive but symmetric and transitive. Question number 2. Given X is equal to A, B, C, D, R equals AA, BB, AC. So what is given for R? It is AA, BB, AC. Now we need to include some more pairs from here. A, B, C, D, there are 4 elements. So X cross X means 16 elements will come. Which all should I include so that it will become reflexive, symmetric, transitive? My first idea, reflexive. What do you mean by reflexive? Out of the 4 letters, A is there, B is there. Reflexive means A related to A. So what all should be there? AA, BB, CC and DD. Given 4 letters, I should have AA, BB, CC, DD so that R will become reflexive. In the 4, AA, BB are given in R. So what should I include? CC and DD should be included. My question is, what should I include to make it reflexive? So these two should be included into R for reflexive or to be reflexive. The second idea, symmetric. What do you mean by the word symmetric? Just see AA, BB, AC are there. Symmetric says whenever A, B is there, I should have or R should have B, A. The idea, whenever AB is there, R should have BA. So AA is there means, again if I reverse also AA it is there. BB is there, reverse also BB is there. So AC is there, so what should be there? CA. So whenever AC is there, R should have CA. AA, BB, even if I reverse, it is AA, BB only. So what should I include? CA. So we will write C, A should be included into R to be symmetric. The third idea, I want to check for transitive. Now what is transitive idea? A related to B and B related to C implies A related to C. Check it. Now AA is present, AC is present. If I cancel A and A, AC should come, that AC is there. BB is there, with B there is no other pair. So nothing to be included. So for transitive, nothing needs to be included. We have everything in the set itself. The fourth idea, equivalence relation. What do you mean by equivalence relation? The given set should be reflexive, symmetric and transitive. So all that we said, let us include here. What all I must include? Reflexive means C, C, D, D. Symmetric implies I should include C, A. Transitive nothing. So these pairs should be included if I want the relation to be equivalence relation. So CC, DD, CA should be included into R so that R will become an equivalence relation. So the question claims minimum number of pairs, not all, not maximum, minimum. So 1 or 2 only, which only I have to think and include. So reflexive implies I should have all the 4 letters, the pairs AA, BB, CC, A related to A. This is the idea of reflexive. So AA, BB are already given. I should include CC and DD. Symmetric tells me whenever a pair is given, check the reverse is there. So AA is there, BB is there. AC is present should imply CA should be included. And transitive, B nothing starts, AA means AC, it's already there. So nothing needs to be included. For equivalence relation, combine everything and write the answer.